Okay, here's a few different parts for the mini gas pressure lab. I got a bunch of things all in the video frame at the same time, but here I've got a syringe and a marshmallow. I'm going to put the marshmallow into the syringe so it goes all the way to the bottom, and then put a cap on the end of the syringe so that it's going to be airtight. And then if I put the piston in the end of the syringe like that, you can see the marshmallow in there. And if I push on the piston, the gas in the syringe will become compressed. I'm going to decrease the volume of the pressure or increase the pressure of the volume in the syringe, and as a result, the marshmallow will shrink down. And that's because as the pressure of the air in the syringe increases, the volume has decreased, and all the little air bubbles that are inside the marshmallow themselves have also decreased in volume. I'm going to do this a different way. I took the cap off. Now I'm going to push the syringe piston all the way down and put the cap back on. Now I've got a fixed volume of air inside here. And then if I pull on the piston, the pressure inside here will decrease. And as the pressure inside decreases, the pressure in the air inside the marshmallow will also decrease. And now the marshmallow has inflated. So that's an observation for the first part of the lab. For the second part of the lab, I have these soda cans, and the soda cans have some water in the bottom, and they're on a hot plate and they're boiling. You can see some water vapor coming out of the top. So I've got hot gas inside the can itself, and I'm going to quickly grab the top of the can and then invert it into this bucket of ice water, and that will rapidly cool the gas that's inside the can. And as the gas inside the can is rapidly cooled, you'll see a change happen for the gas inside the can. So here we go with the first one. You see it cause a dramatic change in the can. I'll just do the other two too, just for fun, just because I've already got them hot. There's the second one. And here's the third one. That one was pretty good. That one crushed vertically too. Okay, and then the last part of the lab is the Cartesian diver part of the experiment. The Cartesian diver, there's a stopper, or a dropper bottle inside this 2-liter bottle, and the dropper has some air inside it. So you can see a line between where the water in the dropper and the air in the dropper exists. And let me slide this stuff out of the way. I'll hold it like this. If I squeeze the 2-liter bottle, what happens is the volume of water inside the dropper increases and the volume of air inside the dropper decreases. So I can control the height of the diver inside the container by controlling the pressure. You'll notice that the place where the air and the water have an interface or meet, that changes. So the water line goes up and the air becomes more compressed inside the container. So here we go. I've got it relaxed, and then I squeeze it and it dives down and let it go, and the thing goes back up. That's called a Cartesian diver. You can see better videos on YouTube of the action of Cartesian divers that are like filmed a little bit better. So just Google Cartesian diver. That's C-A-R-T-E-S-I-A-N, Cartesian diver.